Hello students and welcome to Byju's classes. Today in our class we will very briefly discuss the topic of gravitation. So what is gravitation? Gravitation is the weakest force among all the other fundamental forces. What are the other fundamental forces? The strongest to be considered as the strong force or strong nuclear force. Then comes electromagnetic force, as you all know. Then comes the third, weak force or weak nuclear force. And last but never the least comes gravitational force. So what is this gravitational force? Gravitational force is a kind of force of attraction which is exerted by all the objects in the universe having mass in them to all the other bodies in the universe, right? So each and every body of the in the universe exert gravitational pull to all the other objects. Like this marker I am having, this is also exerting a gravitational pull, and this board I have behind me, this also exerts a gravitational pull. I also exert a gravitational pull. All the objects in the universe exert gravitational pull to all the other objects. Okay, so now in Newtonian mechanics or classical mechanics, we have a very nice formula to define gravitational force. So let us see the formula and let us understand how that formula works. So students, as I was saying, there is a very beautiful formula for gravitation. As you can see behind me in the board, you can notice I have written the snippets of the formula separately. First, it explains that the force of gravitation is directly proportional to the product of masses of the two bodies that we are considering, right? Let the mass of one body be m1 and the mass of the other one be m2. So the force of gravitation would be directly proportional to the product of the masses. And also the force of gravitation depends upon the distance. And how? It depends inversely. That means longer the distance, weaker the force of gravitation gets. Closer the distance or closer the two bodies are, the stronger the force of gravitation gets. So if we combine both of them, and according to mathematics, we change this sign of proportionality to make an equation. We have to provide an equal to sign in the equation, and to change the sign of proportionality to the equal to sign, we need to introduce a proportionality constant. So in this case, the proportionality constant we are introducing is capital G. And what is capital G, my students? Capital G is universal gravitational constant. So let me write the formula and explain it to you. So students, in my back you can see I have combined both the snippets of the formula and converted this proportionality sign into an equal to sign by introducing a proportionality constant, that is capital G. And what is the value of capital G? It's 6.67 multiplied by 10 to the power minus 11 Newton meter square per kg square. Okay, you need to remember this unit. And what is it called? It is known as universal gravitational constant. It's a universal constant. It never changes wherever you go in the universe. Okay, the value is a very small value. As you can see, it's 10 to the power minus 11, right? So this is how the formula of gravitational force looks like. All right, so this value is a very small value, students, and that is why if you have two objects, like for example if you take my weight or if you take any other person's weight and you put here, for an average let it be 60 kgs and this one let it be 50 kgs, right? Both of the masses. And if you calculate the value by putting our weight, our daily life objects weight in this formula, you can see the answer that comes up is very small. It's around in the range of 10,000 or millionth of a Newton, right? So that is why for our daily objects like this marker or us or table, chair, bed, anything, for our daily objects the feeling or the effect of gravitational pull is imperceptible or very minimum. All right, but where can we feel the effect of gravity? In large objects like in planets, in solar system, galaxies, sun, stars. There we can feel the effect of gravitational pull very effectively, because the masses of planets, star and all the celestial objects are huge, right? So the effect of gravitational force is very like strong in the celestial objects. And as we can see that the effect of force of gravity is inversely proportional to the distance squared. So the distance between the center of both the objects, and if you square them, so it is inverse square, it follows an inverse square law. Let me show you a graph to demonstrate that how the distance or the square of the distance between the objects affects the gravitational force. See students, this is the inverse graph how gravitational force get affected along with the distance. You can see it never becomes zero, right? The value can get infinitely small, but it never becomes zero. It varies by the square of the distance between the objects. So students, this was about all gravitational force. We also have other topics like acceleration due to gravity, and how the effect of gravity is gets nullified, or all the effects of cumulative gravity gets nullified, the effect called superposition. We have all this to learn, and we will do this in the next classes. So I think student, this brief discussion will help you very much understanding the fundamental formula and the fundamental force of gravitation. Thank you very much. We'll meet you in the next class.